Hi guys, assalamu alaikum. I hope you're all well and having a good day. So basically today I'm back with another very important video where I will discuss regarding the most difficult and important multiple choice questions from the Edexcel levels physics unit 4. So without wasting any more time, let's start. Let's start with this one. This is a very important one because this is one concept which is assessed by the examiners in section B as well. So let's start. It says the diagram shows the paths of two charged particles x and y. Here you guys can see the direction of x and y has been given. Moving at the same speed in a uniform magnetic field. So basically they have the same speed and they are in the same magnetic field. I mean, they're in a uniform magnetic field. Which row of the table describes the properties of y compared with the properties of x? So basically they are saying about the properties of x and y. Now here, one thing that you guys will have to understand is both of them are moving in a circular motion. Both x and y are moving in a circular motion. So we can say there is a centripetal force acting on them, right? There is a centripetal force acting on them, and the formula of force on a moving charged particle in a magnetic field is denoted by BQV, right? This is the formula which denotes the force on a charged particle in a magnetic field, and here this force is our centripetal force. So we can say this is equals to mv square by r, right? Mv square by r. If we actually move this formula, this v and v gets cancelled out and we are only left with r is equals to mv by bq, right? And here, as they have said that they have the same speed and the same uniform magnetic field, so this speed and this magnetic field will not be into consideration because both of them are the constant. So the radius solely depends upon the mass and the charge. So radius is equals to mass by charge, right? Now let's have a draw true radius in this for these two particles. Now let's draw a radius like this and let's make it big. Let's make it big like this and keep it right here. So basically this is how it looks like. Let's make it a little bit, yeah. So here this is like this. So if we draw the radius for this particle, the radius will be somewhere right here, right? This radius will be this big. I mean the radius will be this big, right? Now for this particle, the radius will be this because the center is right here. So basically this has a much greater radius. X has a much greater radius and R has a smaller radius. And if someone has a smaller radius, then definitely his mass is going to be small and charge is going to be high because radius is inversely proportional to charge and directly proportional to the mass. So as they have compared for Y, we can say that Y will have a mass lesser. So it will have a mass lesser and a charge greater because its radius is small. So we can write our correct answer is going to be this one. And this concept is very important. The diagram shows the track of a charged particle in a magnetic field. The magnetic field is directed into the page. Alright. Which of the following could create this track? So basically one thing we know previously is that in a track, it can be either a positively charged particle or a negatively charged particle. But here what I can see is right after seeing this track, I can assume that the track is moving from y to x. The track is moving from y to x. Why the track is moving from y to x? Because here what you guys can see is the radius of curvature has decreased. Let's say this was the radius at the start. This was the radius at the start, though it was way bigger. The radius was like this, right? It has a very big radius at the start. For the start, I mean for this position, this is the radius. This is how big the radius is at the start, right? Now at the end, in the direction of y, You guys can see the radius has become this small, or even that small actually. So now the radius has become even more small. So basically the radius has decreased. The radius has decreased as it has moved from y to x. The radius has decreased. So as the radius has decreased, we can say it has moved from y to x, because in a particle detector the energy decreases. The energy of the particle decreases. So the radius also decreases. So as the radius also decreases, so we can say it has moved from y to x as its radius has decreased. So straight away we can remove the point A and C, because it says from x to y, and we know it is not from x to y, it is from y to x. Now the question remains whether it is a positron or an electron. I mean whether it is a positively charged particle or a negatively charged particle. And we know the magnetic field is directed into the page. And as the magnetic field is directed into the page, we will have to use the Fleming's left hand rule right here. And while using the Fleming's left hand rule, the first thing that you guys will have to understand is um, in a particle detector, or or the track of a charged particle is such that um, a positively charged particle will move in the same direction as the current. As the direction of current is the correct direction of current is in the same direction to the motion of the positively charged particle, whereas the direction of the current is in opposite direction to the direction of motion of a negatively charged particle. Now let's figure out where actually the current is. Where the current is, let's figure that out first. Now we know the magnetic field is directed into the page, and let's take this one as the motion of the particle at y, and we know the force is always perpendicular to the direction of motion of a particle in a magnetic field, right? So we can say the force is in this direction. The force is in this direction. If the force is in this direction, now let's figure out the magnetic field and the direction of the current. We know the magnetic field is into the page. Now let's figure out the direction of the current. So as the current was showing in this direction, so basically the direction of motion will be in this direction, right? If it was a positively charged particle, then the direction of motion would have been towards the right. But here we can see it is moving from y to x. So the direction of motion is in this direction. So the direction of motion of the particle is in the opposite side to the direction of current. So we can say it is a negatively charged particle, because a negatively charged particle has a direction of motion opposite side to the direction of current. So we can say our correct answer is going to be D. And this is a very important question because it was a little tricky. So make sure you are understanding the Fleming's left hand rule in detail before your physics unit 4 exam. So basically one thing that you guys can see here is the force is in this direction, right, which is the blue arrow, and the magnetic field is into the page. So if I bring my if I use the Fleming's left hand rule, we know this is giving me my direction of the force, right? So my force is in this direction, and we know the magnetic field is this one, and the magnetic field is into the page, so it will be like this. And if the magnetic field is into the page and it is like this, we know the current is towards the right hand side. This is the force which is acting upward, like just like the picture, and this is the magnetic field which is into the page, because the question says the magnetic field is into the page. So if the magnetic field is into the page and the force is upward, just like my hand right now, then the current will be towards the right. So let's draw the current in the right direction. Now this question says a wire is in the same plane as a magnetic field of magnetic flux density B as shown. The wire is of length L and carries a current I. Alright. Which of the table gives the magnitude and direction of the force on the wire? So basically we know the formula of force is BIL, right? Force is equals to BIL. And the force on the magnetic field should always be perpendicular to the direction of the current. The magnetic field will always have to be perpendicular to the direction of the current. Now as the direction of the current is in this direction, so we can say our sorry, the current is in this direction, so basically our magnetic field will have to be in this direction to be perpendicular, right? So if this is the line which is like this, if we draw it like this, if the magnetic field is like this, and this one, and this is the theta, if this is B, then as it is with the angle, so we can say it is B cos theta, right? This is going to be my B cos theta. So my formula will be BIL cos theta, right? So my correct answer will be either A or B. We can remove the options C and D. This is very important to understand, that the magnetic field and the current will have to be perpendicular to each other. Okay. Now the question remains whether it is into the page or out of the page. Now let's solve this one using Fleming's left hand rule. As you guys can see, the direction of the current is upward and the magnetic field is downward. Now let's use the Fleming's left hand rule. According to this, this includes my force, this gives me my magnetic field, and this gives my current, right? So now we will have to figure out the direction of the force. Now we know the direction of the magnetic field is like this. The magnetic field is acting downward. Here you guys can see here that the magnetic field is acting downward and the current is acting upward. The current will be acting upward. So basically, as the current will be acting upward, the magnetic field will be like this. So the current is acting in this direction, just like the picture you guys can see here. The current is acting in this direction and the magnetic field is acting like this. So we can draw it like this, that the current will be like this and magnetic field is like this. So the force is into the page, the force is going into the page, right? This is how it looks. The current is in this direction, the magnetic field is downward, and the force is into the page. So our correct answer will be force into the page, which will be the correct answer, A. So our correct answer will be A, because it is into the page. Alright, so now let's solve this question number 6. It says a positron and a muon travel at the same speed through a magnetic field. Alright, so they have the same speed. The magnetic field is directed into the page. So alright, the magnetic field is directed into the page. Which of the following diagram best represents the motion of the particles? Alright, so it says about the motion of the particles. Now this is a very tricky question. It is a very in-depth question actually. Okay, so it is a very in-depth question, but it only gives 1 marks, but it requires a lot of thinking in order to solve this question. Now we will have to understand the particle physics. We know muon is a lepton, right? And electron is also a lepton. But here it is an antiparticle, which is an anti-lepton actually. But both of them are leptons. Both of them are actually leptons. And we'll also have to understand that leptons start from electron, neutrino, muon, neutrino. So basically electron, neutron is my first generation, and muon is my second generation. And as positron is an antiparticle of electrons, it will be in the first generation, and muons will be in the second generation. And as muon is in the second generation, so basically it will have a greater mass. Muon does have a greater mass. Its mass will be greater because it is in second generation. As it is in second generation, its mass will be greater. And we know if someone has a greater mass, we can also say if someone has a greater mass, its radius of curvature will be greater as well, because we know P is equals to BQR. If someone has a greater mass, its momentum is going to be greater as well, because momentum is equals to mass into velocity, and as its momentum is greater, its radius is going to be greater as well. Now, so basically as it will have a greater radius of curvature. Now we can see in the part B, the muon does have a greater radius of curvature, as its radius of curvature is like this, which is big, right? whereas the positron's radius of curvature is small. It is way smaller. It is like this, right? It is like this. Its radius of curvature is actually small. So it will be either B or our answer will be C, because C also has a muon having a greater radius of curvature, whereas A have positron greater radius of curvature than the muon. So A and D cannot be our answer, because D also says positron will have a greater radius of curvature. So basically this cannot be our answer. Our only answer will be between B and C. Now the next part will be regarding the direction at which the muons and the positrons will be going. So for this we will have to use the Fleming's left hand rule. Okay, we'll have to use the Fleming's left hand rule. And here, as you guys can see, that both of them are moving upward, so we can say that our magnetic field is directed into the page. We know this finger shows the magnetic field which is directed into the page. Right, our magnetic field is directed into the page. If the magnetic field is directed into the page and the current is moving upward, so we can say this is our current. So current is moving upward and the magnetic field is going into the page, so our force will be towards the left. Our force will be towards the left, so a positively charged particle will spiral in the left hand direction. So it will spiral. So as the force was in this direction, so basically a positively charged particle will spiral in this direction, right? The positively charged particle will spiral in this direction, so positron is going to spiral towards the left. So we can say our correct answer is C, because here the positron is curving in the left hand direction, and positron has a smaller radius of curvature than muon, which includes all the things that is required. So our correct answer is C, and this question was a bit tricky, so make sure you are understanding each and everything and you are applying them. Try to remember them as well. The diagram shows a particle track in a bubble chamber. Which of the following is a valid conclusion from this track? The first one they says is the particle is negatively charged. Now to assign whether a particle is negatively charged or positively charged, we will have to know the positive side and the negative side of the particle track. Here in this track, they haven't given us whether this one is the positive part or this is the negative side of the track. As they didn't give us the positive and the negative part of the track, we cannot assign whether this particular track is negatively charged or positively charged, right? If let's say it was positive side and it was negative side, now a particle moving in this direction, the particle moving in this direction will mean that yes, this particle is a negatively charged particle. Why? Because the negatively charged particle is moving towards the positive side of the bubble chamber, right? Because negative attracts the positive and the positive repels the positive one, right? This is the way we can assign whether this is a negatively charged particle or a positively charged particle. But here, as they didn't give us the positive and the negative side of the bubble chamber, we cannot assign whether this is a negatively charged particle or a positively charged particle. The point B says the particle is moving from X to Y. They didn't give us any direction. They didn't give us the direction like this or this. So we cannot say whether it is moving from X to Y or from Y to X. So this answer cannot be a valid conclusion as well. They have said about the valid conclusion. Okay. They have said about the valid conclusion. The next part says the speed of the particle is increasing. Now they are saying that the speed of the particle is increasing. This cannot be our answer as well, because the speed only depends upon the radius of curvature of the radius. The radius of curvature, the speed solely depends upon the radius of curvature, and here there is only one radius, and that radius is uniform. Let's say if we draw like this, okay, let's draw it like this. Here you guys can see that the radius is constant. So this is how the radius will look like actually. Let's make it even bigger. So this is how the radius is. And here the radius is constant. This is the radius which is constant. The radius isn't changing like the way we have seen in the previous questions that the radius is changing. So here the radius is not changing. So we can say the speed is not increasing. We cannot conclude that the speed is increasing because it is here where the radius is constant, uniform, the radius is uniform. Next part says the particle experiences a centripetal force. This is the correct answer. Why this is the correct answer? Why does the particle experiences a centripetal force? Because it is moving in a circular path. It is moving in a circular path. As it is moving in a circular path, we can say yes, it experiences a centripetal force. Otherwise, it would have never moved in a circular path. There must be a force acting perpendicular to the direction of motion, and that force is our centripetal force. So yeah, we are done with this question. A proton is accelerated by a uniform electric field. After time t, the speed of the proton has increased by del v. A helium nucleus is accelerated by the same electric field. So now here they're comparing proton with a helium nucleus. You will see these type of questions a lot of times, that a proton will always be compared with a helium nucleus, or a helium will be always compared with a proton. This is a very common question in physics unit 4. After what time will the helium nucleus achieve the same change in speed? So basically they're asking about the time, after what time they will have the same change in speed, and the change in speed was equal to del v, right? Now let's talk about the uniform electric field. As they have given us the uniform electric field, we know the formula of electric field, right? Which is force is equals to we know electric field strength is equals to force per unit charge. So basically here force is equals to electric field strength into charge, right? And we know electric field strength is equals to force per unit charge, so we can derive this formula like this, which will become we know here the formula of force is mass into acceleration, right? So we can write E is equals to mass into acceleration divided by the charge. And here this acceleration can be denoted, we know the formula of acceleration is del v by t, right? The change in velocity divided by the time taken. So E is equals to m into del v by t divided by the charge, right? And as here they have asked us about the time, we can make t the subject, right? We can make t the subject. So eq will be equal to eq is equals to m into del v by t, and from here we will make t the subject, so it becomes t is equals to m into del v by eq, right? M into del v by eq. Now this is the general formula for the t. Now let's derive the formula of t for the helium nucleus. And we know the helium nucleus will have a mass greater 4 times greater than the mass of the proton, and the charge 2 times greater than the charge of the proton. Let's write the configuration of proton right here. We know the configuration of proton looks like this 1 1, right? The configuration of proton is like this, and this is the configuration of helium. We can see that helium or helium has 4 times greater mass and 2 times greater charge, so that's why we can say like this, right? So now let's derive this one. So here the next t will be is equals to mass will be 4 times, so 4 m del v divided by 2q into e, right? 2q into e. So we can actually derive this formula. We have derived this like this. Now t is equals to we can write this down like this as well, not 2q. We can write it down like this 2eq, though this q, this 2 is for this q, right? So we can write it like this. Now it becomes we can say that m del v eq is the same, right? They have remained the same. They have remained the same, just there is a difference of 4 by 2. So we can say t is equals to 2 into this value is the same as this t, right? So we can write 2 into t. So the new time is 2 times the previous time. So our correct answer will be B. Are you guys still stuck in chapter 1 while the exams are racing closer? Are you guys still watching videos on YouTube, but your marks are not increasing? It's not you actually, it's the method. Let's fix it. Welcome to Exam Essentials, where every second counts and every session hits. You have seen the paper solving videos, right? And you have watched the YouTube walkthroughs as well. Now it's time to do the full course with us, this time for real. So basically, we have launched our A levels high impact crash course for the October 2025 and the Jan 2026 session for the subjects mentioned below, which are physics, chemistry, maths, biology, economics, business, information technology, and accounting. Now let's know what is included in these courses that we are offering to you guys. So in the month 1 and month 2, basically there we will complete the full syllabus. Let's say if you are an AS physics candidate, we will complete the syllabus of unit 1 and unit 2 in month 1 and 2. And if you are an A2 physics candidate, we will complete unit 4 and unit 5 on month 1 and 2. We will complete the syllabus in detail using our AI generated videos as well as simulations to make you guys understand tricky stuffs very easily. And then what we'll be doing? We'll be doing intensive past paper solving from all the recent question papers from Jan 2020 to Jan 2025 on the upcoming months, which is the month number 3 and 4. And this is not only the things that we'll be getting, there will be a few more things as well. The thing is, you will get the access to 50 plus previously recorded question paper solving videos. You have watched my question paper solving videos on YouTube, right? But there are 50 more question paper solving unlisted videos of mine, which you guys will get after joining my course. That is not in the YouTube. As well as those videos, you guys will also get my digital notes, my mega revision worksheets, which works like a magic. The mega revision worksheets are just a magic, and a few more things as well, supplements and worksheet booklets and many more things. And here you guys will also get the live and recorded sessions. The classes, you guys will get around 3 classes every week, which will be around 1.5 hour. So you will get the videos of those classes as well, which you guys can rewatch anytime. And I will be available for you guys 24 hours 7 days. You guys can ask me any questions in our WhatsApp group or Messenger group. I'll be there to answer your questions. Now, why will you actually join my courses? You guys have watched my video and you have enjoyed my video, but why will you guys join my course? Because the result of my students speaks for themselves. So basically you guys can check the recent results of my students. So basically don't waste your time anymore. Join my course to excel in A levels physics. You can contact me on on my Facebook page Exam Essentials or at my WhatsApp number, which is given right here. An alpha particle also moving in a straight line. Okay, so it says also. Now this means something, that we are comparing alpha particle with something. This also means we are actually comparing alpha particle with something. Moving in a straight line with the same speed enters the magnetic field. So basically the speed is the same. It's very important to annotate like this while reading the questions. It decreases your chances of doing mistakes. The alpha particle follows a circular path in the magnetic field, which of the following is the initial radius of the path. All right. So basically they didn't say to whom they are actually comparing this alpha particle. So we know they will always compare it with a proton, nothing else. It is very common that they will always compare it with proton. Now let's write the configuration of alpha particle. We know alpha particle is the same as the helium, right? Alpha particle is same as helium, which has a configuration like this, 4 2, right? And proton has a configuration just like hydrogen, which is hydrogen is 1 1. And they have said they are moving in a circular path, and when something is moving in a circular path, we know their formula becomes, we know there is a very famous formula, which is momentum is equals to BQR, right? And they have asked us to compare the radius. So radius is equals to P by BQ, which can also be written as MV by BQ, right? All right. So now they have said about the initial radius. So the radius is something on which we will have to work. They have said the same speed. So basically the hydrogen and the helium, both of them have the same speed. So we can eliminate this one. This is not that important right here. And this B represents the magnetic field, right? And the magnetic field is also the same because both of them are moving in the same magnetic field. So this is, we don't need to take this into consideration. So basically the velocity and the magnetic field is constant. So the ratio becomes R is equals to m divided by q, which is mass to charge ratio. The radius depends upon the mass to charge ratio. Now compared to hydrogen, helium has 4 times the mass of the hydrogen. Helium has a 4 times the mass of the hydrogen. 4 times. Why? Because it has a mass number 4 times the hydrogen. And about the charge, we know charge depends upon the proton number. And hydrogen has charge of 1 and it has a charge of 2. Helium has a charge of 2. So we can say there is a charge 2 times charge, 2 times more charge. So basically this helium is the alpha particle and this hydrogen is the proton. So we can say R is equals to, the mass is 4m and the charge is 2q. So ms by charge is equals to R. We can say this R is equals to this R is equals to 4 by 2, or we can also write it down as only 2 because 4 divided by 2 is 2. 2 into this m by q, which is the same as this one, right? So you can say 2 into R. So basically our answer is the initial radius of the path will be 2r. So our correct answer will be B. This is the initial radius of the alpha particle on this path. Alright, so now let's solve this very tricky electric field question. It says the diagram shows the shape of the electric field pattern between the two charged particles x and y. So basically this is one charged particle and this is the another charged particle, which is x and y. X has a charge of minus q. Which of the following could be the charge of y? Now the options that they have given us includes both the positively charged particles and the negatively charged particles. And also there are two types of magnitudes. One is 2 and the other one is also it can be either 2 or 1, right? The magnitudes are either 1 or 2 and the charges, right? So basically the thing that is the thing that matters is the sign and the magnitude. So these are the two things on which the options are given, right? So we will have to actually think on these two things. Now let's do it. Now on what actually the sign depends? The sign depends whether the two electric fields are attracting or diverging, whether they are attracting or diverging. Now if they were attracting, from here what I can see is the electric field of x and y is diverging because y is moving away as well as the x is also moving away from y. Basically x is moving away from y and y is moving away from x. None of them are attracting each other. None of them are attracting each other. They are not actually going through one another. So basically they are moving away from each other. So we can say both of them will have the same charge, right? They will have the same charge. So basically our y will be a negatively charged particle as well. So we can directly remove option C and D because it cannot be positive. So this is how we will be looking after it. As they're diverging, they're moving away from each other, both the electric fields of x and y. So we can say y is a negatively charged particle just like x is, because the same charges repel, right? Now let's have a look at the magnitude. Now the magnitude actually depends upon the null point. So what is actually the null point? Let's draw. Null point is actually the point where there is no electric field pattern. Null point is actually the point where there is no electric field pattern. This is what the null point is. Now here we can see this is the point, I mean this is the point where there is no more electric field, right? This is the point, there is no more electric field, so this is the null point. Now the null point is closer to that particle which has a magnitude smaller than the other one. So now let's see which one is closer to the null point. So this is x has a distance this much and y has a distance this much from the null point. So basically we can see that y has a greater distance from the null point and x has a smaller distance from the null point. Now the charged particle which is of a greater magnitude will have a distance greater from the null point than the particle. So basically as y is at a greater distance from the null point, we can say y has a greater charges, greater magnitude of charge. So we can say y will have a charge is minus 2q. So our correct answer will be B. Why is it minus 2 and not minus 1? Because the distance from the null point of x and y is not the same, and y has a greater distance from the null point. That's why its magnitude of charge will be greater. So the only option that remains is minus 2. That's why we have given it as minus 2q. And why minus? Because both of the electric fields are moving away from each other. They are not attracting. They are repelling each other. They are not going through each other. They are moving away from each other. This is the main way to explain this question or to understand this question. This was a very tricky question. Make sure you understand each and everything in detail. If you have any, now let's have a look at this question. It says a gamma photon of energy 18 mega electron volt produces a particle and its antiparticle. So basically a gamma photon is producing two particles. One is a particle and the other one is an antiparticle. So basically this is a question of pair production, right? This is a question of pair production, something that we have learned in our syllabus. So basically there is a photon, okay, which is 18 mega electron volt. So we can write it is 18 mega electron volt, which will produce two particles. One is positive and the other one is antiparticle. So let's say these two particles will have mass because you have created a particle, so that particle will definitely have a mass. So they have asked us the maximum possible mass of the particle. So basically it is saying of one particular particle, not the both the particles. So the maximum possible mass. So let's say this is the positive particle and this is the antiparticle, and we know the two of the particles will get equal share of the energy. So they will have 9 mega electron volt and he will also get 9 mega electron volt. Now this is the energy that they have got from the gamma photon. Now let's figure out the mass of this energy. As it is the energy, we will have to convert them into mass, as the question says maximum possible mass. So now let's convert this one into mass. We know one thing, that del E is equals to del mc squared, right? So if we have to figure out the mass, we'll have to divide the energy by c squared. So del E by c squared is equals to my del m. So here del m is going to be 9 mega electron volt. So we'll have to convert them into mass in kg. We'll have to convert this mega electron into kg. So 9 into 10 to the power 6 is what mega electron volt is, and for mega it's 10 to the power 6, and for electron volt it is 1.6 into 10 to the power minus 19 divided by the c squared, which is 3 into 10 to the power 8 squared. So our correct answer will be D. Hopefully you guys have understood this one. Two equal positive charges are placed at y and z. So basically y and z, both of them are positive charge. Point x is equidistant from y and z. So whenever they mention point x, that means it's a point charge. Okay, it's a point charge. This is a mark scheme language that you guys will have to understand. Which of the following shows the direction of the electric field at point x? So basically where the electric force will be exerted on point x. Now as y and z, both of them are positively charged, as well as the point X is also positively charged because because it is a point charge. So as Z is itself positively charged, so it will repel, right? So the force will be in this direction. As well as the Y is also positively charged, so it will exert a direction force in this direction to the X, right? It will not attract, it will not exert like this, it will exert like this. So let's draw the force right now. The forces of Z will be in this direction, and the force exerted by Y will be in this direction, right? Now as both of them are in angle, we will have to break them down into components. So this will be my horizontal component for the force of Y, and this will be the horizontal component for the force of Z, right? And as both of them are in opposite directions, they will cancel each other out, and the vertical forces will be in this direction of both Y and Z will be in this direction. So this is the direction at which the force will be actually acting, right? And this will be the direction of the electric field as well. So we can say our direction of the electric field will be answer B, right? And as these two are in opposite directions, the horizontal components, so basically both of them are in opposite direction and are of equal magnitude, so they will cancel each other out. So now our correct answer is B. When a point object with charge plus q is placed at distance d away from another point object with charge plus 2q, the force between them is F. All right. The charges are increased to plus 2q and 4q. The distance is measured, the distance is increased to 2d. Which of the following gives the new force? So let's figure out the force for this one, which was plus q, and the other one was also plus q, and the distance was d. So we know there is a formula, F is equals to k theta 1 theta 2 by r square, right? So it will be, all right, so first one was theta, so theta into 2 theta divided by d squared, so it will be k 2 theta squared by d squared, right? This is the formula. Now let's for the F new. So for F new, it's k into 2 theta into 4 theta. So we can say 2 theta into 4 theta is 8 theta squared, right? So 8 theta squared can be written like this. It can be written as 8 theta squared divided by d squared, and the d is 2d. So 2d squared means 4d squared, and if you divide both of them, it becomes k 2 theta squared divided by d squared. So basically this is exactly the same as this one, so there is no change in the force remains F. So we can say our answer is C, because this F is equals to this F, right? This one. So we can say new F is equals to previous F, or so the new force is equals to the previous force on the F. There is no change in the F, so we can say answer is C. The question number 8 says a wire is held firmly in place between two magnets mounted on top of an electric balance as shown. The reading on the balance is 1.500 Newton. The magnetic flux density between the magnet is 0.007 Tesla. When the wire is connected to a circuit, so there is a current in the wire, the reading on the balance is 1.503 Newton. So basically when the current is flowing in the wire, the balance reading increases. So the reading on the balance increases. That means the reading on the balance will only increase if there is a force downward, right? If there is a force downward, only then the reading on the balance will increase. So basically the question says which of the following gives the direction in the ampere and its current in the wire and its direction. So basically it's saying about the wire. So the current in the wire and its direction. So for the current in the wire, here we will also have to use the Fleming's left hand rule. Okay, we will also have to use the Fleming's left hand rule. Now it says on the wire. So basically this force downward was exerted by the wire on the balance, but we are talking about the current in the wire. So when we are talking about the current in the wire, we will have to take into account the force that is acting on the wire. So according to Newton's third law, there will be a force acting on the wire upward. So there will be a force acting on the wire upwards. As there is a force acting on the wire upward and the magnetic field is from the north pole to the south pole, if we use Fleming's left hand rule, we will figure out that the current's direction is towards the right. So we can say from x to y, right? And there is a formula. So our correct answer will be either A or C. So let's figure out what the formula says. We know F is equals to BIL, and now here we will have to figure out the current. So the formula will become I is equals to F by BL. So here the force is the change in the force, which is the difference in the force, which is 0.003, which has changed from 1.500 to 1.503, divided by the magnetic flux density, which is 0.07, into the length of the wire in the conductor, which is 5 centimeter, which needs to be converted into meter, which is 0.05. So our correct answer here will be B. Alright guys, I hope everything has been clear so far and you have understood each and everything till now. So if you want to solve more question papers with me, or if you want to solve the mega revision worksheets of exam essentials, which works like a magic just 7 or 10 days before the exam, and if you want to solve all your problems of the recent question papers with me on live sessions, you can join my question papers marathon course for the A2 physics. My common questions videos and the predictions of AS physics were spot on. 20 to 25 marks from my notes and predictions has come on the AS physics exam. So why to waste time? You guys can join my A2 physics question papers marathon course to ameliorate your A2 physics unit 4, 5, 6 exams, because the predictions and the mega revision worksheets are going to be very important for your A2 physics May 2025 exam. So without wasting any more time, message us at our WhatsApp number or at our Facebook page to join A2 physics, chemistry, biology, maths question papers marathon course. The diagram shows a potential difference applied across two conducting parallel plates. Point X is midway between the plates. Which of the following is the electric field strength at point X? Now this question becomes really easy because they have asked us about the electric field strength. And we know there is a formula of electric field strength, which is E is equals to V by D, right? And they have given us the potential as well as the distance, right? They have given us both of these things. But the question is not that easy, to be honest. The difficulty becomes about the direction, whether it is upward or downward. Now let's think it of point X. Now we know they have given us point X, and when they denote by saying point X or something by writing point, that means it's a point charge. It's a point charge, and we know point charges are always positive. And if there is a positive point charge right here, if there is a positive point charge right here, then this positive potential will exert a force downward, right? Because the positive potential will repel the positive point charge in the opposite direction. So basically it will have a force downward. Now we have got that it has a force downward, so our answer will be either B or D. Now let's figure out the electric field strength. So E is equals to V by D, right? Our V has been given us 10 volt divided by our distance. Okay, now it will exert the force over this whole distance. It will be 20 into 10 to the power minus 2, which will give us a value of 50 volt per meter downwards. So our correct answer is going to be B. A 6-volt battery is connected across two parallel metal plates. Which of the following shows the electric field lines and equipotentials in the region between the plates? So basically, before solving this question, we will have to understand some things. These are very important concepts that you guys will have to remember between the potentials, and I usually see that most of the students don't understand them. The first point is potential is maximum at the positive plate. The potentials are always maximum at the positive plate. And the second point is the potential gradually drops to zero at the negative plate. So basically, if the maximum potential will be at the positive plate, and it will decrease till coming to the negative plate, and it will decrease to zero at the negative plate. And the field lines always flow from the positive to the negative plates. Now, if you have understood all of these 3 points, this question shouldn't be a difficult way to do it. Now, let's see the option A. It says, you can see it is flowing from negative to positive plate. So we cannot say it is correct because the field lines are flowing from negative to positive, which should have flowed from positive to negative. And B number, it is also the same. It is flowing from negative to positive, so it's not the correct answer. And here it is flowing from positive to negative. Yes, it's correct, but it is going from a smaller value to a bigger value. No, potential is always maximum at the positive plate. So basically, it will go from 4.5 to decrease to 0 at the negative plate. So our correct answer will be D. And this was a very important concept. So please remember it. A coil of wire is connected to a resistor as shown. The magnetic flux density of the field through the coil is increased steadily from 0 to a maximum value. Alright, which of the following single changes would result in a smaller current in the resistor? So they want smaller current in the resistor. So here we will have to see one thing right now, whether the coil and the resistor are in series or parallel. We can see that the resistor and the coil both are in this, they are joining by the one wire, by a single wire. So both of them are in series. As both of them are in series, we know the current flowing through the resistor and the coil will be the same. You can see here that they are connecting through the same wire, so it is in series. Okay, now as the current flowing through both of them is the same, we cannot decrease the current through the resistor. What we can do is we can decrease the current through the coil, which will decrease the current through the resistor. So to decrease the current through the coil, we will have to decrease the EMF induced in the coil. We'll have to decrease the induced EMF in the coil. So what we can do is we can say, if we have to decrease the EMF, we know EMF is equals to dn phi by dt. So to decrease the EMF, we will have to increase the time taken to reach the maximum flux density. So our correct answer will be D. And why we are decreasing the EMF? Because decreasing the EMF decreases the current flowing through the coil, which decreases the current flowing through the resistor as well, both of them are connected in series. A sphere traveling at speed v collides elastically with an identical sphere which is at rest. After the collision, both spheres move off at an angle theta to the direction of travel of the first sphere as shown. The spheres have the same speed as each other. What is the speed of the spheres after the collision? So basically they're asking the speed of the spheres after the collision. Now in this question, there is a very important thing that you guys will have to be able to notice as soon as you read the question. This is this part, which says the spheres are elastic. I mean, they collide elastically with an identical sphere. So as they have collided elastically with an identical sphere, we know when two identical spheres collide elastically, the angle between them will be 90 degree. The angle between them will be 90 degree when two identical spheres collide elastically, right? Now, to answer this question, they have said the speed of the spheres after the collision. So basically, we'll have to figure out the speed of the spheres, okay, or the speed of actually one sphere. The speed of, let's say, this sphere. So to figure that out, we'll have to draw a vector triangle. Now let's draw the vector triangle for this one. It will be vertically downward, not vertically downward, at an angle actually, and it will be upward, right? So it will be like this, and this one was our initial, right? Initial velocity. So the initial velocity is in this direction. So we have drawn it like this because it has to be in tip to tail. Both of them needs to be in tip to tail, right? This is what the rules of vector triangles say, right? So it will be in, so this will be our v, and this is our final velocity, and this is my final velocity. So I will have to figure out the velocity of one sphere. So we can say, we can write it down like this, and that v squared is equals to vf squared plus vf squared, which can be written as v squared is equals to 2vf squared, and we know vf squared is equals to v square by 2, and here we'll have to make vf the subject. So velocity of f is equals to root over v square by 2, which becomes this square and the root over gets cancelled out, so we can say v divided by root over 2 is equals to the velocity of one of the spheres. It says what is the speed of the spheres, that means what is the speed of every sphere. So the speed of one sphere. So our correct answer is going to be C.